Thank you for having me, and today we're going to talk about gaming construction, gaming technology and construction. Really, it's about collaboration, a multiplayer experience. So what does that mean? I'll get into it. So before I get started, I just want to talk about our history a little bit. So for almost 2 decades, Mortenson's been performing BIM and VDC on our projects, really focused on driving value to our customers. Finding the best and newest technologies to help us deliver an exceptional customer experience. So over the years, we've kind of honed our skills and experiences to deliver a standard of work that we feel really proud of. And this is just one of the examples today that we're going to be talking about. So, so why is a construction company interested in gaming technology? We know the design teams, the architects, the engineers, they've been using technologies like this for a little while now. But the construction industry is really driven behind informed decisions. Any design process, any construction process, the success is driven by the best decisions. And those best decisions happen when they happen early enough, happen in the design phase. So we're looking at technologies that allow us to really drive enhanced decisions early on during the design phase, because once decisions are made, they can then be, they have a downstream effect, which allows us to better plan for prefabrication, better plan for our scheduling, and more certainty in our cost. So we're leveraging the best technologies available at our disposal to be able to do that. And I apologize for the blurriness of the slides here, but the graphs that you see here are graphs that came out of research through the University of Minnesota. And what it really shows is the dark blue is in a traditional process, and the light blue is the process used with gaming technology. The first one is about client understanding. The second one is about accelerated feedback. The third one is, I can't even read it, perception. So looking at something on a screen versus kind of experiencing the space. So you can see by the abstract graph that the traditional versus the new process is dramatically improved. So today we're going to kind of look at how we're leveraging these type of technologies to drive enhanced decision making. So today I'm going to go over some of our live R&D projects that we have performed over the last couple of years. We're going to look at the scientific approach through research through the University of Minnesota. And then kind of get into a single player experience and moving into a multiplayer experience. And hopefully all this will start making sense as we go forward. So between 2012 and 2014, we said we're going to try this technology and start applying it to our projects to see what is the real value behind it. So here's 4 examples on the use of the technology. The first example was really about the customer. On the Sanford Health project, we used the Oculus Rift and some other gaming technologies with the help of the University of Minnesota, the VRDL laboratory. And we were able to create an immersive environment so our customers were able to walk through the space that drove their business. So for healthcare, it's the patient rooms, it's some of the public spaces, the ORs. That's what drives our customers' business. That drives revenue for their business. So what we did was, working with our design partner, we developed this immersive environment and brought in the nurses, brought in the folks that actually made the decisions about these spaces and had them actually experience these spaces in a full immersive environment. The second example is on the Vikings project, where the authority and the city and the team itself needed to understand what the exterior look and feel and the lighting of the parks around the facility is going to look like during the day and during the night. So what we did was we brought the model into a gaming engine called Lumion Quest 3D, and that allows a level of interactivity. So what you can't see here, but the exterior of the project has a lot of these lighting poles that are part of the design, and they're pretty large, as you can imagine, the size of this facility. But the decisions needed to be made around what does this look like during the night? What's the fan experience going to be? What is it going to do to the neighborhood? So we're able to use the gaming engine to actually turn on the sun, turn off the sun, and once the lights went down, the lights of the facility turned on, so that the customer and the team were able to understand in real time what that environment looked like, which allowed a better informed decision process. The third is at the University of Minnesota, the residence hall project, and we had it's a dormitory project, so we had a lot of repeating rooms. So you make one decision to one room and it applies to a lot of the other rooms. So we actually took the model and put it into the VRDL facility, which I'll get into in a little bit, and that allowed our user, our customer, to be able to make decisions on the lighting, on the bathroom stalls, and some of the dormitory rooms to be able to help reduce costs or drive certainty in cost and schedule. And finally, the fourth one is the Penn State Pagula Ice Arena, where we use the six-sided cave system, and that is basically a 10 by 10 room with projections on all six sides of the square, and allows multiple users to kind of walk in the space and be able to experience the space. So we brought in the athletic director, and they used it for recruiting for new athletes, so this way they can experience the space before the project was ever built. So I'm going to talk a little bit about that. The University of Minnesota project, the 17th Street Residence Hall, it was kind of a first approach, and we didn't really have a key goal to address for this project, so it was more like a live R&D. So what we did was we took the 2D information and the 3D model information from our design team and our contractors, and we brought that into the VRDL system. And they have this pretty wild system. Is anyone familiar with the University of Minnesota's VRDL? So raise a hand. We have a couple of folks in the room. It's pretty exciting. You put this headset on like the Oculus Rift. It has like a weird Christmas tree on top of it. But you can have multiple people fully immersed in this space. And we did that with the University of Minnesota customer, and it allowed them to be able to drive value into the system. So they felt like they were part of the design process, and they were part of the construction process through the immersion. We did this, and it could have saved that, you know. It could have saved two weeks of time, saved about $3,000. So we didn't have any true objectives behind that. It was more R&D. The next project, the Pagula Ice Arena, we said, all right, we're going to leverage this technology in the cave environment. We're going to then basically measure every instance in which there was a change in the immersion space or the cave, and what was the downstream effect of that. So overall, we had the architects, we had the customer, the facilities teams, all kind of walking through this cave environment for different parts of the building, the stadium, the back of house, and we basically measured every time there was a decision made during the immersive environment. And overall, we'll share this presentation with the audience, so this way you can actually see the metrics. But we saw a $500,000 return on investment by doing this, and this all happened during the design phase. So before we actually started buying out the materials, and before things that actually impact construction happened, we were able to do that early on. So we saw a $500,000 savings by using the immersive environment. So we said, all right, what are the plus and deltas? What are the things that went well, and what are the things that did not go well? So we saw that there was high interactivity, there was versatility in the process, there was immersion. And the idea about immersion is that we're typically seeing something on a screen. We're perceiving it on a screen or in a 2D drawing. And your brain has to go through a level of translation. You have to translate it, you have to interpret the information. What the immersion allows you to do is fully experience a space. It's a one-to-one scale, you're fully immersed. How many gamers are in the room? Don't be shy, come on. All right, there's more. I know you have closet gamers in the room. The spatial cognition is the other part of it. So being able to put yourself actually in the space allows you to fully understand the space, the architecture, the feeling, the emotion that the space will provide. So it provides a better informed decision process. And finally, it's a multiplayer experience. Multiple people were able to experience the space at the same time. We saw that as a fantastic plus. Some of the deltas was the timeline of creation. To create this information, it impacted the design process. The design team had to do more work. So we said, what can we do to help that process so we don't impact the design process? The workflow, there was multiple steps, multiple parties involved. We had to set up the model in-house, send it off to the VRDL or the cave environment. They had to put it in Unity and all this stuff. And there was a really unfortunate workflow there that is not easy in our business, design and construction. So the physical installation, we had to fly customer, nurses, folks to the actual physical location, and that's a challenge, right? Having to get a C-suite person or a team of people from the customer side to a location for one meeting is not easy. So the model rework, the material depiction, there's some skill levels involved in that. So not everybody knows how to optimize textures and models for gaming engines. So, and one of the deltas was there was a single player perspective. The cave, the cave environment, one person drives the perspective for the others. So that was the plus delta. So we started doing a little bit more work. And in like 2014, we started investigating Unity, Oculus Rift, and different headsets and different gaming engines like Unreal. And so what we did was on this project here in town, on most sports facilities, locker rooms are a big thing for the team, for the players. So one of the things that happens on large NFL and sports projects is there's an off-season and on-season setup. So off-season, there was a lot more players in the locker rooms that the team had to share. So we basically wanted to show the athletic team that during the off-season and on-season, the lockers that were in the middle of the space provided enough room for the rest of the players. So we actually had players and the athletic director kind of walk through the space with the Oculus Rift, and they were able to say, yeah, actually, it feels right. It has enough space. So it allowed the team to provide us input to feel more comfortable about the design. So it allowed our design team to have more confidence and allow our customer to have more confidence. And then downstream effect, it allowed the construction team to better drive certainty into the cost and schedule. So the K-State project, again, in 2014, the head coach and the athletic director was really concerned with the materials and lighting of the locker rooms. Again, locker rooms are a big thing. Apologize for the quality here, but once the team actually put on the Oculus Rift and was able to see and actually feel the space in a fully immersion experience, they were confident on the design. So really, no changes happened. And the worst thing that could possibly happen from a designer, from a builder, all right? How many folks do DIY stuff at home? All right? How much rear work is involved in that? There's a lot. How many trips do you take to Home Depot? A lot. Doesn't it suck when you have to redo something? Well, just think from a professional standpoint, we do not like to redo our work. All right, it's a pride thing. We're builders. We want to build it right the first time. Even though we may build it right, the worst possible experience is when our customer walks into the space and says, it's good. That sucks. That's the worst feeling. We want them to come in and say, wow, this is exactly what I envisioned. The designers knocked it out of the park. The builders knocked it out of the park. That's what we want. And this is the type of experience we want to provide during the design phase in a virtual reality setting. And that's what this technology is allowing us to do. So the Oculus Rift, the plus and the deltas were about, there was a better workflow, the immersion was good, the spatial cognition was good, the mobility was super positive because now we can take the immersion to our customers. We can have multiple units sent out to Missouri and to Seattle and Minneapolis and have them experience the space. The delta was it was still a single player experience. You put on the Oculus Rift as one person. So let's get in. So I'll get into that a little bit in a minute. So in 2014 we said, all right, let's focus on the scientific approach. How do we really get the data behind driving value? So what we did was we joined the consortium of research practice out of the University of Minnesota and partnered with the VRDL facility. And we had a student, his name was Will Adams, and he did research. It was called Spatial Cognition recognition for virtual reality. So what he did was he set up 4 methods to help us understand what is the difference between looking at something on a monitor versus physically versus virtually and fully immersion. So the first step, the first step was to create a control. The control was really a physical space. So we set up these 4 markers in the study, and these markers had the test subjects walk around them in the physical space. And then they had to go and recreate that, so rebuild that based on what they experienced. We then had the second process was looking at a 2D monitor, a 3D model on a screen, and then going to actually build the space. So it's, again, it was 4 or 5 markers they had to pull around. And then the third was using a head-mounted display, so the Oculus Rift, and sitting and kind of experiencing the space and going to build it. And then fourth was actually going through a fully immersion space, walking around it virtually, and then going to build it. And what we did was measured that. So again, it's hard to see, but the control is the physical space. So actually physically walking through the area and then going to build it was the control. That was the baseline. We measured everything against that. So this is the control. So this point here is that baseline. Every other scenario, the second, third, and fourth, measured against that. So we measured the deviation. So the second one was the 2D monitor. So when the test subjects looked at a 2D monitor and then went to recreate it, there was a larger gap. This is the deviation between control and the next subject. So there was a large deviation between looking at something, perceiving something, and then going to have to build it. Third was the Rift. So the Oculus Rift, you can see the gap, the deviation gap is a lot less between because there was a one-step immersion. They actually physically put something on, they were immersed in the space, they actually walked around it virtually, and then they went to recreate it, so there was a less deviation. Finally, the fully immersive walk, where they actually put this head unit on, moved around the stage, moved around the experiment, and then we built it. We saw the least amount of deviation. So the data shows that the more immersive an environment, the better connection to reality. So this way we better perceive something. So that was the first kind of real study done like this from an architectural engineering construction standpoint. So, Will Adams, we since hired him. He's a rock star, and we're doing a lot more cool stuff with him and the University of Minnesota. But the key lessons learned with the workflow, using gaming technologies, testing, all that stuff needs to stay in-house. Once we send it over the fence to somebody else, we lose that value. Second, decisions are multiplayer. In no project, one person makes the decision. It's always done as a team. There's multiple players involved in making decisions. So having multiple people experience the space at the same time drives value. Accessibility. Making the system mobile was key. So in 2014, we said, all right, let's take all our lessons learned and figure out a way to create a mobile solution. So back in 2012, this is the VRDL system. You can see it was a backpack, it was wires, it was tethered, but the person was fully immersed. In 2014, this is pretty funny, you guys can laugh. They upgraded the system, and again, there was a prototype in 2014, and the value behind this was they were able to find a better solution, a more affordable solution to drive it, and it was the iPad. So moving from this massive desktop, a $3,000 setup, to a $600 setup with a 60 frame per second refresh rate, we said let's figure out a way to make that big system into a mobile unit. so we can take it to Fargo and Minneapolis and anywhere we wanted to take it. So this way we can get multiplayers in this space in an immersion state to be able to really drive value. So this is just a couple of months after that proposal, and I think this was May of 2014. We had multiple people in the space. You can see the markers there, like number 3 is, Mihal, and I'm the other guy over there. So we're actually able to see each other in the virtual space, multiple people experiencing the space. And then this is, and again, I'm not talking a lot about gaming technologies like the tools, but all of this is about fully immersion using gaming technologies. So again, the idea is this is in the big space at the VRDL, but our focus is moving it into the mobile space. So you can see this was in May. We can skip to the next one. And then continually improving. The VRDL folks are pretty excited about this technology, and so are we. They now added avatars. So by like the end of last summer, you can play this one too. They actually had multiple people with 3D avatars in the system. So this is the 17th Street Residence Hall project that we built a couple years ago. But now imagine having the person who's going to run the building, the owner. Someone just came through the wall, yeah. But so you notice the heads are moving. So imagine having a virtual meeting where you have someone at their headquarters, somebody in the architect's office, someone in the contractor's office, and they're all experiencing the space at the same time. And someone's asking a question, and they're saying, yeah, no, that doesn't work, all right? But that will help drive better decisions. So what we do, we're working with our design partner. We're working with our customer and the rest of the team. So this way, the design team, their workflow is not impacted because they send us the model. Mortenson, we then take that information, we work with the interior designers to get the lighting, the textures, everything ready, and we set a purpose to the meeting with our customers, and we say, these are the 3 things we want to get out of this meeting, and we use this type of immersion environment to drive decisions during the design phase. And then the value we're seeing out of it is tremendous. So here are the folks involved at the University of Minnesota. I feel like I'm doing a commercial for the U, but the reason why I'm bringing this up because we have some awesome experts in our backyard, and we have to leverage academia more. For the last 10 years, a big part of my role at Mortenson was to partner with academia across the country and develop research because those are the folks that are going to help drive us to the next point. Our vendors are looking at them. Autodesk was at the VRDL last year at the CTC event. But Lee Anderson kind of is heading up. He's been doing research on VR for the last 20 years. We have Aaron. Renee Chang is the director of the School of Design. She kind of runs this program. And Phil Radar. So these are the folks that I've been working with. And please, I know some of you know those folks. Reach out to them. They're doing some really exciting things. And that's kind of all I had. But I think I made my time, right? All right. So thank you.